Let's talk about guidelines, core guidelines among other things, mostly guidelines that we have in projects. Short introduction, my name's Arne. I work at Züge, that's our logo above there. At Züge, I work mostly in embedded projects. Before that, I've done a couple of enterprise financial software stuff. C++ for quite a while, but also other languages before. And I do some trainings internally, sometimes externally for C++, maintain no code, that kind of stuff. So the context for the talk is I have in the last 9-ish years at Züge been in about 12 projects, different customers, different settings, small teams, big teams, teams that are solely from our side, from the contractor side, teams that are mixed between us and the customer side, so different experiences and so on. The one common baseline that all these projects have is some kind of style guide document or coding guidelines and so on. So let's see a quick show of hands. Who has this kind of document in their current team or the current work? Okay, who does not have those? 1, 2, okay. So you're familiar with kind of these documents, right? Most of you. Depending on the projects, sometimes we have like a huge document given by a huge corporation and the team just says, yeah, that's them. The document is like 20 years old. We don't follow it anyway. So then why have the document? Others are relatively maintained. Some are inspired, for example, by the C++ core guidelines, by other guidelines. Some are inspired by more ancient wisdom, like things that have been transported over the years, sometimes decades, sometimes multiple decades. And so we will have a look at a few of those and see what we can learn from those. Speaking of wisdom transported over the years, jack of all trades, master of none. What does that mean? I mean, this is a common saying, right? So usually when I hear it and when I see people use it, it's interpreted as can do everything a bit, but nothing really good. Like a bit of a negative. That's not the original meaning. The original saying was jack of all trades, master of none, but oft times better than master of one. Meaning we need generalists. I've been in lots of projects where we had like 4 or 5 people. The testing specialist, the front-end specialist, back-end specialist, database specialist. Yeah, documentation, I'm just a tester. I don't do this kind of stuff. Yeah, like code generation, that's not what I do, right? And I have been in a project where I had experience in C++, and it wasn't used at all in the project. So I am a specialist for C++ in a project where no C++ was used. We did JavaScript, Java, bit of Gherkin testing, bit of Python scripting, which I didn't know at the time. So I learned all this kind of stuff. And I was better in the end. I was basically the jack of all trades. Or like one of our product manager put it, the Swiss Army knife developer, which was quite cool. I got back to C++ back then, but we need generalists. So we will see a couple of guidelines that are found in different projects. Heavily biased pickings of guidelines that were not spelled correctly. So it was not all bad in those projects, right? So this is a disclaimer. They had pretty good guidelines in those projects. But some of those guidelines were like, yeah, we will see them. And we can learn from them. And then in the end, I will have like a section of guidelines about guidelines, what we do with them in teams, what we do with these guideline documents. A guideline found in the wild. define or delete all copy, move, and destructor functions. Rule of 5. Who has heard of the rule of 5? A couple of hands. Is this the rule of 5? If you look at the C++ core guidelines, it says C21, if you define or delete any copy, move, or destructor function, define or delete them all. The if is important. The one before said, always do this, always do all the 5. If you do one of them, do the rest. More important, C20. If you can avoid defining any of those, do. Avoid them. So the meaning is usually, if you have to define one of those, then it's usually because you're doing something like memory management, any other resource management. You open some file, you have to close them again. Usually what we say in RAII class is responsibility, acquisition is initialization, which in fact means destruction is responsibility, release, but the other way around. If you have to do this, then usually you also have to care about the others. In many cases, this starts with a destructor. Oh, I have to free some resources here, or I have to roll back some action if it has not been committed, or I have to do some cleanup. And then in copy operations, you have to take care, do we both need to do the cleanup, or do I transfer the cleanup, or maybe I clone the memory and the resource, or whatever. So this is why we need to take care about copy operations. The same for move. Usually in a move operations, the responsibility of dealing with whatever we have to do moves from one object to the other. So if you see code in the wild that has one of those but not the others, then one should get suspicious. Did they forget the move operations? Maybe it's old code that does not care about move operations. If you only have copy operations and a destructor, then the compiler, due to compatibility reasons for old C++ 98, will delete move operations for you. So there does not happen anything fishy. So if you want those move operations, you have to put them back in. So if you see a class that has 1 or 2 or 3 of those 5, but not all 5, you usually should be suspicious and look into what's going on here. So in the other way around, to document, yes, I have thought of all of these, copy is perfectly okay. How the compiler does it, then use default, equals default. Or say, I don't want this to be copied because resource management, then use equal delete, and it's not copyable. That's the reason for the rule of 5, and it is there in this guideline document in the core guidelines C21. So this, in contrast, does not really hold. So what's the impact? What we see when we have this in the code in our guideline document? We see people write all the 5 all the time. Tons of boilerplate. Maybe they know about the equals default part, maybe they don't. It can lead to these constructors and destructors being non-trivial. So you're copying your objects actually calls a constructor that does in the end nothing, instead of just using a memcopy, what your compiler can do when it's a trivial object. Some people say, I have not really thought about this, so I just equal delete all the move and copy operations, which makes your objects maybe less usable. Or they say, okay, I don't want to make it less usable, I just write equals default for everything, which when you have resources and you don't think about it, maybe you have the wrong code and you actually do copy stuff. This was called the rule of 5. So what are we talking about here? Rules or guidelines? I think this is a pretty famous quote from the Pirates of the Caribbean, that their code of law or whatever is more what you'd call guidelines than actual rules, meaning it's just a guideline. I don't have to follow it always. The rule is more something that you have to follow it. So the actual rule of 5 is pretty much a rule. You should follow it. Guidelines are usually more like guidelines. However, developers love rules. We love to being told what to do, because usually we have tons of things to talk about, to think about. We have to design classes, we have to solve problems and stuff like that. And when we have rules which will just say, do this, do this, do this, we are happy to follow them. It's less cognitive load. One thing less to think about, right? Just automatically do this stuff because the rule tells us to. We're used to dealing with rules because our compilers and tools already do. We can't persuade the compiler, don't just generate me different code here, right? The compiler has the standard that they have to follow those other rules. No exceptions. And when we have rules, they often can be checked automatically. In fact, the C20 and C21 can be checked automatically, for example, by clang tidy. There's a rule for that one. Guidelines, less strict. There are exceptions usually. So in those guideline documents, you usually have a more or less long paragraph about when these guidelines do apply. It's more freedom for us. We can just ignore them. But it's also more responsibility for us. We have to think about when we should ignore them, when we should not ignore them. So guidelines are often worded like with words like these: avoid, not don't do this, but avoid doing this because there are reasons, but that doesn't mean never do this. Prefer to follow those guidelines, consider something else. Consider explicitly says, think. So this specific one, please don't. Look up the one from the core guidelines. If you define one of the 5, define the other 5 or delete them. So I talked about tooling a bit. Clang tidy. Consider using automated tools for your guidelines. Clang tidy has, especially this one, CPP core guidelines, special member functions, is the one about the rule of 5. If you use this tooling, do you really need this rule in your guidelines document? If you don't follow it, your tooling will tell you so. It will give you a warning. CPP core guideline special member function, I found something. You can take this one, look it up, and find what's behind it. Find what core guideline is behind it. So you could leave it out of your guidelines document to have less cognitive load when going through the document, because the document can get really large if you put everything into it that you want to follow. Something to consider, to think about. Another guideline found in the wild. Don't use exceptions. Who has heard of this one? Lots of people, great. The origin is we do not use exceptions at Google. And I don't know how it is quite now, right now, but like 10, 15 years ago, Google was all the hype. They were the cool kids. Everybody does what the cool kids do, right? So if Google does not use exceptions, we do not use exceptions. Sorry? Bloomberg didn't do it either, okay.
Not because of that, it's because of legacy hardware and it being super expensive on those legacy hardware. And it's just...
Yes. So I had just yesterday a conversation with a Google person who told me, well, that's they did have this originally because back in the day when they wrote this down, having exceptions was relatively costly in your code, so compilers could not optimize the presence of potential exceptions away as good as they can now. Right now, if you don't throw an exception, having exceptions on doesn't do much to your code. Only when you actually have to throw them and catch them, well, then your code gets slowed down a bit, but it's an exception. So it should be an exceptional case, and you shouldn't use it for like normal code flow handling. I've seen that one as well. Right now, when you look at these guidelines from Google, they state nothing about the performance part. They say, for existing code, the introduction of exceptions has implications on all dependent code, because the code that uses your throwing code has to be ready for exceptions to be thrown, right? Most existing C++ code at Google is not prepared to deal with exceptions. We're not talking about hundreds of thousands or millions of lines of code here. We're talking about billions of lines of code. So making all that ready for exceptions, probably not something they want to do in this century. So our advice against using exceptions is not predicated on philosophical or moral grounds, but practical ones, because basically we cannot use exceptions because that would make our code brittle and unsafe. Things would probably be different if we had to do it all over again from scratch. So they would like to use exceptions. At least that's what I interpret from that last line. So if you have a smaller code base or start out completely fresh, just because Google does it is no reason for us to not use exceptions, right? I have worked in projects where we could not use exceptions. Those were tiny, small-scale embedded projects where you cannot use exceptions, because adding exceptions to executable adds, like, depending on the compiler, 20 to 30K byte to executable. And when your chip only has 40K of RAM, then that's quite considerable, right? So the impact of this one: exceptions are part of our language. If we don't use exceptions, we cannot use parts of our language. We cannot use a language as it is designed to be used. We can't use large parts of our standard library because all the containers that allocate memory throw exceptions. Newer types, still optional, still variant, and so on, throw exceptions. So if you can't use exceptions, you can't use those newer types. They are there in the language to make error handling more robust, because an exception you cannot ignore. A return code from a function you can forget to query, to check, and if there's an error, you just ignore it and you just go on and get weird results, right? It also has impact on code quality, because, well, if I call a function that has a potential error return code, I have to check that error return code and pass it back to my caller if I can't actually handle the error. If I can't handle the error and I use exceptions, then I don't have to do anything. The exception just go through, stack unwinding happens, and some other function further up the call stack has to handle the exception. So it makes functions that actually do not have to deal with these errors easier to write, easier to test. Context matters. Many of the guidelines that we see out there are not universal. It depends on the project. It depends on your code base, on the surrounding code base, whether they apply to you or not. So please don't use this one unless you work at Google or Bloomberg, or you have another huge code base. So there are smaller code bases, even like last project I was on had like 20-ish million lines of code. Luckily, they were already using exceptions, but even 20 million lines of code, updating those to actually be exception safe can take a while. Next guideline found in the wild. Every function shall have a single return statement, SESE. Yes, yes, no. Have you heard of this one? There are multiple sources for this one. For example, here, A function shall have a single point of exit at the end of the function. MISRA CPP guidelines or coding conventions based on this document IEC 61508, functional safety, which is something that applies to, for example, stuff in automotive and similar things where you have machines that run this code and these machines can actually hurt humans. There you want to have functional safety. I've had a customer where they were doing something with self-driving vehicles, and a couple of years back there actually has been heavy incidents where people really got hurt because the vehicle did not just did not care about that there was a human in front of it. But does this apply to all code bases? Maybe not. So there are regulations for certain kinds of software that you may develop, and then you have to apply these regulations. And then you have these regulations, and in these regulations it says you don't have as you shall have a single point of exit at the end of the function, and that's okay. And there are checkers for those. But if you have those regulations to follow, do you need a copy of this one in your coding guidelines? Probably not. Your coding guidelines should have a link. These are the regulations that we have to follow anyway. There's a counter argument to actually not do this if you are able to not use these regulations. There's a thing of guard clauses called early return. If the pointer I got passed is a null pointer, just go, return. If something else is not right, just return. I have no internet connection, just return. Okay, all the stuff I checked is given, now I can put my logic here. Instead of, well, having all the checks and then still go through the logic or pass the logic because all my checks failed. It's like, because if you can only have one return, then it's at the end of the function, right? Also in C, when you have resources, you might want to go for a single return because you have to all the cleanup at the end of your function. And you don't want to have like, okay, if this is a valid file name, open the file. And now if I cannot read the file, close the file, return. But at the end of the function, you also have to close the file and return. And all this kind of stuff, it gets really brittle really fast. I have seen code bases where instead of early returns, you had just a simple go to cleanup, and then you basically do what the compiler does in C++ for you, do all the cleanup. But still, in C++, use RAIL classes, classes that close your file handles for you, classes that clean up your memory, close your database connections, whatever. And then you can just return, and the compiler will take care of the rest. Again, context matters. If you have to follow external standards, there's no way past this, but those external standards maybe don't belong into your guidelines document because you have the standards document anyway. And often you have automated tools, so the automated tools will point you to the standards document and not to your project guidelines, right? So this was the first part. What about the SE? Any idea what that means? Single entry, single exit. Single entry? Is there more than one way to enter a function? If you work with assembler or with Fortran, yes, there is. In Fortran, you can have like entry points and then just skip past the first 10 lines of this function and start there. In assembler, you can jump from anywhere, or with specific go-tos, maybe in some languages. But that's not C++, right? You can't do this in C++. You can use goto in C++, and the compiler will hit you on your head and say you're going past any of the lifetime things that we have in here. Don't do this. And when researching for the single entry, single exit origin, It turns out that, according to some of the sources at least, it does not mean return from one point in your function, return to one point outside the function, which is a bit different. So you can have multiple returns as long as what you return to is the point past the call side of your function. There are also, Fortran, other languages where you can return in special cases to different locations a bit further down your stack. Well, so maybe this does not really apply. Impact. Anybody has seen variables that are called ret or retval? Yeah.
Yeah, well, the single entry, single exit thing. I think also there are some people that say that you do that because for RVO or an RVO, you get return.
Yes. Yes.
That is a valid case if you care about whether or not that thing you're returning is copied or moved from.
Yes. So the question was, some argue that you do this single return to have return value optimization or named return value optimization. And whether you care about whether this thing is copied or not. I'm not 100% sure, but I think with C++17 copy elision, a lot of this is gone. So, or return value optimization and some parts of NRVO are already baked into the language, and you will get those even if you have early returns. So if you have a function that says, well, if this is not given, or if I'm at the end of my recursion, maybe return 22 and else do this part of the stuff, then this can kick in. But also, do you actually need this optimization? Have you profiled your code to actually need this optimization?
I'm just mentioning.
Yes, yes.
I'm not saying that you need it.
No.
Some people will say that you need it because of.
Yes, people will say that you need it because it does some optimization or it enables some optimization. And yeah. My answer is, if you need it to do some optimization or to enable some optimization, do you actually need the optimization itself? Or is it more important to have clean and readable code? Depends on which part of your code base are in. There may be like tight inner loops where you have like this kind of function where you actually want to do this to enable all the optimizations you can. But then please, okay, it's okay to know that there might be return optimization when you have a single exit and then use a profiler to actually check whether that's true or not, instead of just do this because someone told you that, and so on. So what we get when we try to use a single return, what I see quite often is like a variable called ret or retval. And then when we know what the result is, we assign retval and we try some mechanism or other to skip the rest of our code to get to the end of the function. Reading this, I see, okay, retval is assigned here. There's 50 more lines of function to go. I have to read all these lines of function at least through the if conditions to see, do I go in here? No. Do I go in here? No. Does retval get assigned a different value later? Maybe, because that kind of thing also happens a lot. So knowing this is my return value and immediately returning this value says, okay, I have the simple case, it immediately returns, I don't have to care about the rest of the function. Makes it way more readable. So forcing the single exit or the single return reduces code quality because you have these ret values, you have these bookkeeping values. Is this okay? Do I have to enter the next if clause if not or not? Or you get deep indentations. There is like, if I can open the file and I can read the file content and the file content actually makes sense, then do my logic. Else say the file contents does not make sense. Else say I could not read the file. Else say I could not open the file, which is absolutely unreadable, right? And also Have you considered exceptions? If you throw an exception, this is a different way to exit your function from a different point to a different point. So if you actually want to follow this single entry, single exit, exceptions are not allowed. From what I can see, this single entry, single exit comes from a paper from a certain Edgar Dijkstra from 1970. C++ didn't exist back then. So again, context matters. Some guidelines are based on ancient wisdoms and maybe they don't apply anymore. Or they are based on different languages and they don't apply anymore. So please don't cite rules that do not apply to our language, to your problems, and so on. Next guideline in the wild. Don't use references as members. Have you heard of this one? Nodding, yes. C12, don't make data members const or references in a copyable or movable type. This is the original C++ core guideline. The reason is they make such types difficult to use by making them at least partly uncopyable, unmovable for subtle reasons. Well, the subtle reasons are you can't copy assign or copy move to those types because if you have an existing object, it has a reference or a const member and you can't change those to whatever the object you copy from has, right? You can still usually copy construct them or move construct them because then you initialize that reference or const member. And they have a note, use pointers instead, maybe use the guideline support library not null template to mark this pointer as not null or should never be null. In a copyable or movable type, well, if I add a reference, the type is no longer really copyable, movable, right? So what is meant by this? They mean types that are designed to be copyable and movable. If you want a type that is copyable and movable, that has true value semantics, that you pass from I to B, pass into functions and stuff like that, then you should not use reference members. I have a quote randomizer service that is almost copyable, almost copyable. It has a standard vector, copyable, movable. It has a randomizer engine, copyable and movable. The only thing that makes it non-copyable is the reference to a repository. How would you use this code randomizer service? In this kind of applications, usually you build your collection of services, of repositories, of factories, and then you start running your logic inside them. You only have one of those. You create it and it sits there. You don't want a copy of this one. This is not designed to be copyable. So it's perfectly okay, I think, to use a reference in there because you don't want it to be copyable. It incidentally was copyable before you added the reference, but that does not hurt your design, right? You have not rendered a type that you want to be copyable to be non-copyable. So, as I said, application services, factories, repositories, all this kind of stuff. They have long object lifetimes. They do not have value semantics, so you don't copy them. And they usually are referenced by others as well, so you can't copy them and move them around. There's no need for this. So this guideline doesn't apply to these kind of classes. The reason matters that we have for our guidelines. And the reason tells us when it's safe to ignore our guidelines. And when we just say, well, we can't use reference members ever, then we will have to resort to, I think, less readable types. And also when you're in a corporate environment, telling them, well, yeah, we have this guideline, we now have to include the guideline support library to actually use this kind of stuff. It can take a couple of weeks or months to actually get this approved to use yet another library in your code base. Also, just in case you wondered, yeah, when I just delete my copy constructor and move constructor, then this rule doesn't apply anyway, because then my type is not copyable, movable. Don't ignore the rule of 0 just because you want to make this guideline work, right? So don't be dogmatic. Know or think about when you can really ignore guidelines, because after all, they are guidelines, not fixed rules. Now we get to the spicy stuff. Const goes on the left of the type, west const. The actual rule, at least the header, doesn't say that. It says use conventional const notation. Reason, conventional notation is more familiar to more programmers, consistency for large code bases. This is a recommendation for when you have no constraints or better ideas. This rule was added after many requests for guidance. This rule is not a rule, and even though it's in the guidelines document, it's not a guideline, it's a suggestion for a guideline that you might take up when you have no other idea or other reasons to do so, to do different stuff. So if you have opinions about this, just let it go. It's what they explicitly say. It's okay to make your own conventions because they explicitly say use conventional const notation, right? So even if, especially if in our general C++ community, the general tendency shifts towards isConst, they can just leave this guideline. And then it will mean use isConst because it's a conventional notation. Maybe they have to change their example code, but that's it. NL, the section, is naming and layout suggestions. And they have a big paragraph at the beginning. Yes, these are not real guidelines. These are just for when you have no better ideas, because we have asked by many people who just wanted some defaults they just could apply. So this is absolutely up to you whether you want to have this or not. Also, this can be done by Clang format. Clang format can warn you about this, or you can just say, please format my code, and it will do this if you have configured it accordingly. You can use tooling to check your formatting. So I would say like brace style and all this kind of stuff. How many indentations, 3 spaces, 2 tabs, whatever, does not belong in the guidelines. This is formatting stuff that kind of goes in a formatting configuration file. Clang format will take care of for you. So please don't make me read formatting rules. Just let me use the tool to apply the formatting. And if I read your code base, the existing code base, I see what's going on mostly. The last guideline found in the wild for today. Use singleton for objects that exist only once. Very spicy one. So this is not one of the core guidelines. This is an interpretation of the Gang of 4 design patterns book from, I think, late 90s, something like that, or early 90s, where they say singleton, the intent is to ensure a class has only one instance and provide a global point of access to this class. The latter part is important. They should have turned it around. If you want a global point of access, and incidentally you have only one object of this type, then singleton might be a good idea. Because they say a global variable makes an object accessible, but it doesn't keep you from instantiating multiple objects, especially in C++. This is a thing where you might accidentally copy this variable if it is copy constructible. Or you may, by not knowing, instantiate your own version of it, and then maybe your global logger or whatever the global is does not get used and funny things happen. Use when there must be exactly one instance of a class and it must be accessible to clients from a well-known access point. Just some global static function, get instance or whatever. This is a bit different than use singleton for all objects that exist only once, right? my quote randomizer service exists only once. I instantiate it somewhere in main or somewhere in my domain core, and it lives there forever or until the domain core gets deleted. But I don't make it a singleton because I don't need global access. Impact in a past project, past job actually. We had a code base of 3.5 to 4 million lines of code, and we had 1,200 singletons in our code base, which made the whole thing a tightly coupled monolith. And when we tried to test a single class, this class was using like this singleton and that singleton, and those singletons were then using other singletons, and we had a really long string of singletons on our hands with about 50% of our code base, including a 180 megabyte access database, and executing those unit tests took a while. And due to those singletons also, the whole state of the whole thing was tied together. So they were reading from some database singleton, and if you did not execute the other unit test before that, well, then the database contained different data and your unit test would fail. So all was entangled, and I think the minimum runtime for a cut down set of unit tests that I could actually get to execute and not fail was 25-ish minutes, which makes test-driven development and stuff like that really hard. So interpretation matters. Even the Gang of Four themselves had said that how they wrote it in the first edition of the book did not come out how they meant it. They actually meant it, if you need global state, if you absolutely need it, which you should usually avoid for most cases, then use a singleton because it makes access of this global state safe, because especially when you use modern C++, you can use the static variable inside a function, and it will be initialized in a thread-safe way, so you can even use a singleton from different threads, and the first initialization will be done exactly once, and even though different threads access it. And then you have a use case for singleton, but it should be very rare. An alternative can be dependency injection, though depending on how deep your dependencies go, you might have to inject your global logger or whatever into your facade class, and the facade class then injects it to your subsystem, and your subsystem injects it to another class, and that is injected, so you get like these long chains, and there might be a point where these chains get just too complicated and too long, and then you go back and have a singleton. Something that I think, or I don't know of whether we have a library for that in C++ that I've seen in other languages, Java, C#, and so on, are inversion of control containers. We have one big singleton, and you can ask the singleton, please give me the global logger, please give me the global database access, whatever, and they will give you this, but you have only this one singleton in your whole code base. And you can configure this inversion of control to container to tell it, if someone asks you for the database, give them this class. If someone asks you for your logger, give them this mock or something like that for your testing stuff, which makes it easier to break up all the dependency chains. So don't use singleton for everything. Use singleton only for very good reasons. Which brings me to guidelines for guidelines. So all the examples are done now. What can we learn from them? As a developer, you should understand the context and the rationale for your guidelines, because they are guidelines, they are not rules. So you have to know why they are there and when you have to follow them and when you maybe should not follow them. Also, why are they important for the project? What is our special project context that makes this guideline applicable for my project and maybe not for others? We need a common understanding in the team for when and how to break those guidelines. when you break a guideline, maybe leave a comment, yes, this violates guideline XY, but it does not apply here because, or this is a special case because. Or maybe naming conventions. If something is named as something service or something repository, it's pretty clear that this one is not a value object, so I can probably use references as data members. Discuss stuff in code reviews. Thanks. A suggestion: concentrate on writing down guidelines that you can't automate. Whatever you can automate should give you enough information or a link to enough information to why the guideline you just broke, what the guideline is and what the rationale is, and so you don't have to have a copy of this in your documentation for the developers. Use tooling to check whatever you can check automatically. Developers love automated tools, mostly. They tell us what to do. Great, one less thing to think about. Well, if the tool is about a guideline, then they don't tell us what to do. They just tell us what guideline we have violated, and it's on us to decide what we do about it. If there is one solution and it's very clear they can fix it automatically, then it's not a guideline, then it's a rule, and then we can use Clang format to format our code or whatever. How do we get rid of guideline violation warnings? It may be okay to just turn off this warning in our file or for a single line or whatever. It may be instead be the right thing to actually fix our code to adhere to the guideline. How we fix the code can be a bit more complicated for some guidelines. For example, C12, the one about references, can be checked by Clang tidy, and it has a relatively long name. I think CPP core guidelines, no const or ref data members. And if you use Clang tidy, you can just write / nolint for anything that matches ref or data members, because I just wrote a ref data member. And then Clang tidy says, okay, this one line, and it documents for your colleagues, this was on purpose. I know this guideline. I explicitly ignore it here. Maybe because your class is named service or something. You can do this for the next line. You can do this for the line you put the comment on. You can start a block where you want to ignore specific guidelines and end the block later. So there are different ways. Again, guidelines means freedom. Freedom means responsibility. Don't turn your brain off. Sadly, we just have to think about what we are doing. Also, don't play the metrics. There are things like, yeah, a function should not be longer than 20 lines. If I get the warning, then I have seen people do it. Well, just remove a line break somewhere in between the function, and you have like 2 lines in one line. But for the checker, it's just 20 lines, right? Not the way to go. Also, not break it up in function part 1, function part 2. No good. So find the correct way to actually address those warnings. You know why they are there. You know the rationale, and you know what you violated, and you are best to decide, and the tools can't help you there. How about code reviews? There will be code reviews where guidelines are violated. It might be a mistake. Maybe they don't know the guideline, given that it's not an automatically checked guideline, because you should not review the code where the automatic checker has thrown warnings, right? It might be on purpose and justified. Then maybe your comment should be, please have an explanatory comment in here, so the next one who trips over this guideline violation don't ask themselves, why is it? Or it might be on purpose, but you actually know a better way to fix this. So it's get in contact with whoever wrote the code, find the correct way to actually address this guideline together. Try to keep the document short. No one wants to read 20 pages of guidelines. And the cheap cop-out, we use C++ core guidelines in this project, doesn't work. It's way more than 20 pages. Pick the guidelines that are most important for your project. Match your team situation. There can be teams where everybody is very experienced and very knowledgeable and everybody knows the rule of 5 by heart. Then it's not really beneficial to actually quote the rule of 5 again in the document, right? Because when everybody does it anyway, you don't need this as a specific guideline to follow. If you have regularly new people, then maybe you want to have this in your document. It depends on the software landscape. There may be even project-specific guidelines. We have been in a project where there have been like a bit peculiar uses of the Qt framework. And we had a few sets of guidelines how to actually use these and how to write clearer code and how to write clearer tests actually using these kinds of UIs that we wrote, because it was not straightforward. So we wanted to have like one specific set of styles instead of everybody trying their own and coming up with something different, and it's completely hard to read. So have your conventions, and those conventions are actually a good thing to put in your code base or in your documentation. So maybe you need the rule of 0 and 5 in your guidelines document. Maybe in 2 years you don't. So your guidelines document should not be something that you write now and that is the same document in 20 years. The language evolves, your team evolves, the knowledge evolves, your software surroundings change, everything changes. So from time to time, have a look, does this still apply? Don't throw those old guidelines away, because when you have new joiners that don't know that you have these guidelines and everybody else knows them and it's just in their blood and in their fingers, maybe those new joiners want to have a look at those archived guidelines that were recent a couple months or years ago. But if you have such an archive, it also has to be maintained. I've seen guidelines that had an archive, and we had a guideline where we had actually learned how to really work with this kind of stuff. And we wrote like, don't use a pointer indirection in this case. And in the archive, there was a guideline, please use pointer indirection in this case. So they should not contradict each other. What about in cases like ours, where we work with customers and the customer says, this is our guideline document, you have to follow it. Ancient wisdom, the customer is always right. The actual proverb is the customer is always right in the matters of taste. So if they give you a Clang format file that has like weird indentations or stuff like that, yeah, okay, it's a matter of taste. If they give you guidelines that actually make your code less readable or restrict you in using useful language features, discuss. Because as a contractor or as a service provider, they get you because you're the experts, right? So you can discuss with them and you can give them their expertise, not only in writing code, but also in telling them, in not being told how to write your code. Your mileage may vary. So different teams have different experiences. As I said in the beginning, I have mostly experience in embedded projects, some enterprise legacy code projects, because C++ in insurance, you don't do this anymore. So I hope you got something out of this. Maybe not everything applies to you. After all, those are guidelines for guidelines and not rules for guidelines, right? And with that, are there questions, or please do you have comments? Thanks.